I think we're live. Not live because I'm by myself. This is pre-recorded. Anyways, welcome. This is how to flash your FunBox V3. It's a DIY guitar pedal that is based on the Daisy Seed microcontroller. If you're watching this, this is kind of an additional video to the other video where I talk about the project as a whole, but this is a more technical walkthrough of the flashing process, just because I thought it would be good to work on or to have like a visual that showed the command line, the pedal, and kind of talk through the flashing process, because the flashing part is what I struggled with the most. There just wasn't a lot of step by step, and as somebody who hadn't worked in Git before, and I've never done any of this before, I kind of had to stumble through it. And I want this is already quite an approachable project, and I just want to make it more approachable to anybody who might want to try it out. Hi, buddy. Did you just wake up? Did you do what? Are you hungry? Okay, so right now we have one of the FunBox V3s, and this is Keyth's project. Guitar ML is his username. By the way, fucking stellar dude for this project. I just choked on my own spit. I'm sorry if that peaked the mic. So we have a pedal that is plugged in. We have Git Bash already running. We have Zadig already installed, and the web programmer ready to go. So if you're looking for some of the steps that are leading up to this point, I'm not going to cover those. This is just about the flashing. But the good news for you is I have this project guide which covers the step-by-step of everything that's leading up to this point. And I just flooded this guide with a bunch of additional anecdotes and footnotes and screenshots. Just so if you were as unfamiliar with all of this stuff as I was, you can still get through it. You can do it. You can do it. Anyways, okay, so let's go down to, we have the pedals already ready to, right? It's already built, ready to go. It is plugged in. We have Zadig that installed additional drivers for this microcontroller to communicate with the web, and Git Bash is already installed. So I have the Git Bash window open here. So I'm going to change the directory to the FunBox directory. And if you don't know any command line, I'll give you a couple helpful tips. ls.la, if you're looking at a folder, and in my case, I was in the FunBox folder, ls-la gives you all of the files and folders that are in that folder in a linear fashion. If you just did ls, it shows them to you in this dumb format. I can't read that way. It needs to be in a line. So I always do the ls-la. So I'm going to go into the software directory, and I am going to go into earth, because earth is the effect that I've flashed the most without issue. And let's list those directories again. Cool. So if you are wondering where all of this data is, if you go to your C drive, Boba, please go lay down. Your nails are like chalkboarding. Lay down, please. Please. Lay down. Thank you. If you go into your C drive, users, open the folder for the username that you're currently using, you will see a FunBox folder there, like right here. So if you open the FunBox, you'll see the same files that we're looking at in the terminal directory. So if we go into, well, basically what we want to do now is make the effect. Because I'm assuming that you haven't done that yet. So I am in the earth folder in this Git Bash window here. So I'm just going to put in make and then hit enter. I already made it. I think that's why. Yeah, this is the third time I'm recording this video because I fucked it up the first two times. So I've already hit make, and I've already done that thing, which means if I go into software and into earth and into build, you'll see the earth.bin. That .bin is the effect as like a single file, and that's what you upload to the microcontroller. So let's go back over to Electro, the Daisy programmer web utility. And I want to show you what this looks like. So right now I have an effect on this pedal ready to go. I want to start from the beginning. So I'm going to come down here to flash because I just want to like reset this back to default. The reset routine that you'll see most commonly used for the Daisy is pressing and holding boot, pressing and releasing reset, and then as you can see on the screen, DFU and FS mode popped up. So click on that, hit connect, and then this web utility is going to wipe this microcontroller clean, and it puts a tiny firmware on there that just flashes the LED here. So once it's done flashing, you're going to see that that LED has started flashing now. So we know we're like back at square one pretty much. So the default state of the Daisy is a solid light on the reset side near the reset button, and then a blinking light over on the boot side. So following Keyth's guide, which Keyth, shout out to you. Thank you so much for putting all this together. Go to the file upload, and we're using the default bootloader. There is a second bootloader called the Daisy bootloader, and that is if you click on this bootloader tab here, it gives you information on this. We're not going to do this quite yet. So I'm going to go to file upload. I'm going to hit choose file, click on the earth.bin, hit open, and then hit flash. So if you just hit flash and you don't do anything, the web utility can't find the controller, the Daisy controller, which is this little yellow board here. If I go through that same reset function, press and hold boot, press reset, it pops up again. You can let go of boot, click that, hit connect, and then it's going to go through and it is going to write the earth effect to flash. I cover this a little bit more in my project guide. Again, if you're watching this and you haven't seen the core video, I have an entire guide that covers this project from beginning to end. If this is something that you want to attempt, you should attempt it because it was super fun. It was challenging, but it was awesome. Super happy with the outcome. Keyth mentions flashing effects to the flash storage of the chip and flashing effects to the SRAM storage. And there are like, that changes the routine a little bit, or it changes your steps. Now, unfortunately, I caught it. Boom. Okay, so before we flashed, the LED on the boot side was pulsing, right? Or was flashing. Now that we've flashed different software to this board, it's no longer flashing. So, man, so burpy. That's why, that visual representation kind of helps you know the state that this is in. So that was flashing the effect to flash storage. The other option, which Keyth goes into and I go into in more detail in my guide, is you can flash effects to the SRAM of the chip. The reason being, there are some effects that are too large to be stored in flash storage. And I think he names them. I think they're Neptune and Pluto, maybe, possibly. Don't quote me on that. So you'll go and try and flash, and it'll be too large to fit on flash storage. So you have to go this other route. So I'm going to show that to you now. If you click on bootloader, just leave it on the 5.4 default bootloader version. And again, what we did before is using the default bootloader, and this is called the Daisy bootloader, which is like the more advanced version of it. So I'm gonna hit flash. Again, nothing's popping up. Press and hold boot. Tap reset. Comes back up. Click that. Hit connect. And it's gonna go through the same thing. So we're changing the bootloader of this chip, not flashing a different effect. So there's flashing the bootloader and then flashing the effect. It can be a little confusing. There's a lot going on. So you can see it wrote it. Now, this changes things a little bit because before you couldn't just hit the reset button, but now with this new bootloader, I think you can just hit reset without having to do the boot and the reset thing. We're gonna figure that out together, okay? So now we have a different bootloader than the standard one. Keyth makes a mention in his guide that this programming web utility might not work with some of his effects, but he mentions that he uses it because it's convenient, and it doesn't have any issues. I've ran into some issues here and there flashing things, but it hasn't been, I've been able to get around it so far. So let's say we want to go the command line way of flashing the effects to the pedal instead of using the Daisy programmer. So let's go back to, let me just check the guide to make sure. So make program DFU is how you do that. So again, I'm still in the FunBox software earth directory. So if I type out make program DFU and then press and hold boot, tap reset, and then hit enter, this is how we're flashing the effect to the pedal just using the bash command line. And you can see here, it says defuse interface name internal flash. So this is flashing to the flash storage of the chip. And this process here is doing the same thing that this process was doing. All right, so that finished up. There it is. You're going to see this error 74 here. Keyth makes a mention of this in his guide that error is fine. That's an error that you can ignore. So let's say now we are flashing in effect to SRAM instead of flashing it to the flash storage. And the way that he does that is using the make program boot command. So again, we're still in the earth. So here's another quick tip. If you are in the git bash terminal and you hit up arrow, it brings back the last command that you submitted so that you don't have to type it out again. So I'm going to go back here and I'm going to go to boot, and then I'm going to press and hold boot, tap reset, let go, hit enter. And now this is writing again. This says internal flash again. This is where I got confused before because I thought, I'm wondering now if holding boot and pressing reset goes to the flash, but if I just do a one press of the reset, if it goes to SRAM. I'm gonna see what happens. Let's do this again. Root, I'm just gonna tap reset and then hit enter. Don't think that did anything. Not writable. Let's try one more time just in case. Hit. I'm gonna hold reset a little bit. Press enter. Yeah, it didn't like that either. Let's do this. I'm going to go over to the Daisy programmer. We'll go over to bootloader. And I'm going to now flash the Daisy bootloader to this chip. So leave it on the version 5.4 default. I'm going to hit flash. And if I just hit reset, Daisy bootloader paired. Oh, see, you got to be quick. You got to be quicker than that. Reset. Click. Connect. Attempting to flash incompatible binary. So I think that's the issue I was running into before. It's now making sense. Just hitting reset and then trying to flash the bootloader doesn't work. Holding boot, tapping reset, then clicking that, then hitting connect. Now we're able to write the bootloader. I got so stuck on this for quite some time. It took me quite a while to get past this point and realize what commands were doing what. So that is the SRAM. No, I'm sorry. This is the Daisy bootloader. Okay, that one worked. So now if we come back here, and if I do make program boot, and I hold boot, press reset, let go, hit enter. Now, is it doing SRAM? Hopefully somebody in the comments can tell me what's going on. To provide more help, whatever ends up being the case, I'll make sure that the Notion page that's public is uploaded because I can't change this video after it's been uploaded. But at least you're seeing all of the failures and all of the confusion because this is all confusion that you might end up hitting. So like looking at his guide, right, where it says upload program to Daisy Seed SRAM. And he makes a mention that you have to upload it to Flash first. First, you have to upload the bootloader program to Flash. Do this by connecting the Daisy seed and doing the normal DFU process. Hold the boot button on the Daisy seed, hit reset. Next, upload the bootloader program upload the bootloader program to Flash from the command line. So that's the make program boot. Okay. The command must run from the terminal in the same directory as the make file. FunBox software, Neptune, or Fun. Okay, so yeah, you have to be in that directory. This is because it looks for the SRAM rule in the make file. Okay, so make program boot comes first, and then make program DFU comes second. So let's just do that. Change this to DFU. We're going to hold boot, press reset, quickly hit enter. When's the last time you saw a grown man do that? It still says internal flash, but I'm assuming it's maybe pulling from flash and copying over to SRAM. Not 100% sure. Like I said, I just figured this out like 2 days ago. I've been circling the drain on this one. I tell you that for free. I think that's it. So yeah, so this pedal officially has earth, and because of the changes we made with compiling software, or I'm sorry, I'm just saying words that I'm reading, with using the Daisy bootloader, and I'll show you where in the guide I kind of break this out. So on the compiling the software page, I kind of break it out here, talking about the Daisy web programmer to flash the flash storage, or the git command line to flash to the flash storage, and then the difference between flash storage and SRAM storage, and then the default bootloader and the Daisy bootloader, and then kind of go through these steps. The one thing we didn't cover in this video is using Zadig. Zadig is just a utility that detects the Daisy microcontroller and then installs a driver that allows this board to communicate with the browser. And I had to use Google Chrome in order to make that work. Daisy programmer, that covers through all that. Yeah, so if anybody in the comments wants to make any clarifications, please feel free to correct me, and in the comment section, and I'll update this written guide to make sure that it reflects that. Yeah, hopefully this was helpful, and hope you had a good time with the project. And it didn't go like mine went, but it's okay. We're all good now. Thank you so much for watching. Hope it was helpful, and see you next time. Goodbye.